Helium comes from the Greek word for sun, Helios. On August 18, 1868 in Guntur, India, the French astronomer Pierre J.C. Janssen positioned his prism in the brief moment of darkness during a total solar eclipse. Janssen was one of the many astronomers feverishly anticipating the eclipse, which would be the first since the German physicist Gustav Kirchhoff theorized 9 years earlier that scientists could use spectroscopy analysis to figure out the chemical composition of unreachable bodies like the sun. And we know what eclipse means. That's the obstruction of light from the sun either to the earth or to the moon. So when one of the celestial body, that is the earth or the moon, is in between, and light is prevented from getting the sun by the moon, or light is prevented from getting the moon by the sun, so we have eclipse. So scientists believe that when eclipse arise is an avenue to do some scientific research, especially astronomers and astrologers of those time. And that's one of the things that led to the discovery of what of helium. Based on the aforementioned experiment, as white light passes through a prism, the light splits into rainbow lines of colors, and each element corresponds to its own singular patterns of color lines. Astronomers believed an eclipse was the best time to make those observations. The blanket of darkness that fell across the earth as the moon moved between it and the sun would block the glare from the sun. When the light passed through the prism, Jensen noticed some things funny among the usual spectral lines. A yellow line blazed through, writes Mary Evera Weeks in Discovery of the Elements. The line was similar but not quite identical to that produced by sodium. In fact, the line was so bright that Jensen suspected that it could be observed in normal daylight. Meanwhile, working simultaneously and independently 5,000 miles away, the British astronomer Sir Joseph Norman Lockyer had the same suspicion. He was able to observe solar prominences in broad daylight compared to what Jensen did in the eclipse that we've talked about earlier, and also noticed the odd yellow line. He compared the position of this line with those of similar lines produced by various elements, writes Isaac Asimov in his Words of Science, and decided that this new line was produced by an element in the sun that was not present or had not yet been observed on Earth. Lockyer called the new element helium, after the Greek word for sun. Both Jensen's and Lockyer's paper describing the observations landed at the French Academy of Sciences on the same day, and both men received the credit for the discovery of the new element. So that's the observed helium spectrum, the yellow spectrum. Helium is the second element on the periodic table. Hydrogen is the first, then helium. Looking at helium, helium is having two outermost electrons since helium is the second element on the periodic table. And from that, helium is also a very light gas because hydrogen is lighter than helium, but helium is also a very light gas. And one thing about helium is the first noble gas on the periodic table, and it's relatively inert, and they don't usually react. In fact, nowadays, now because of the reactivity of hydrogen, helium is used in filling balloons because of its inertness, and the mass number is going to be 4, or approximately that thing you can see on top, that's 4.003, approximately 4. And if you want to write the in form of the SPDF configuration, I can write as what as the 1s2. And from that, a lot of things can be said about the element. Helium is a non-metal, although there are a bit of metallic characteristics in it. It is an inert gas, a noble gas or a rare gas, and it is not a metal. Elements that are metal start on the left side of the periodic table of the elements, then they move from there to being metalloids, and on the right side they are non-metals. And helium is on top of the right corner of the periodic table. You can identify if an element is a non-metal or a metal by looking at the position of it in the periodic table of the elements. There are some interesting facts about helium, and one of them is that helium has the lowest boiling point and melting point than any other element. And helium is the second lightest element ever. We've talked about hydrogen as the lightest element. And lastly, helium usually exists in gases except for extreme conditions. Today, the sun element seems to be everywhere on Earth. We inflate countless party balloons with it. We blend it with oxygen in high pressure environments to allow us to dive deep into the ocean. And we use it to cool giant electromagnets like the Large Hadron Collider. But now we are running out of it. Helium is constantly being produced. Uranium and thorium are decaying down in the Earth's mantle and crust. And helium, which is the final product of that, comes sneaking up through it. And some of it escapes through the surfaces and into the atmosphere. And some of it gets trapped in formations in the ground. That's a really slow process. It can take hundreds or millions of years. We are using what you might call fossil heliums, just like fossil fuels. Is what was trapped in the Earth's crust in different formations over time, and we are sucking it out of there quite fast compared to how it was actually trapped and stored. Demand for the element has increased by 10% per year over the last decade, and the price has skyrocketed by more than 50%. As certain industry grow, so does the demand for helium. The element is used in manufacturing optical fibers and to cool military aircraft, for example. In these cases, there are very few substitutes, if any, for the elements. As the helium supply dwindles, helium is expected to continue to be essential in enabling the development of such critical technologies in the future. According to a report in Nature Resources Research, the welding industry uses helium as a cover gas when working with specialty metals so they don't react with oxygen in the air. Liquid helium has a boiling point of roughly 4 degrees Kelvin or minus 452.47 Fahrenheit, which makes it useful for cooling superconducting magnets in everything from local hospitals, MRI machine, and to particle accelerators. Qatar, which is the world's second largest helium supplier, was blockaded in summer 2017. The effect reverberated in both laboratories and companies across the globe. So, what are scientists and industrial users doing to prepare for helium doom? If the price of helium goes up enough or the need for it goes up enough, there is two sources. One is find more wells that have helium in them, and that's possible. And the other one is get the helium out of the ones that aren't worth processing right now. So there are two possible fields of research on helium right now.